All right, in this video, we are going to learn how to find the intercepts of a quadratic given the equations. So there's two types of intercepts, x-intercepts and y-intercepts, and we have to treat them totally differently. Y-intercept is pretty straightforward if you have an equation in standard form. So this is probably not new, but we're going to go through it because the logic behind it is going to help us understand the x-intercept part, which is much trickier. So if you're in standard form, the y-intercept is always when x is 0. Right, so you always have an x value of 0 and then an unknown y value. Okay, now, so if it's in standard form, y equals ax squared plus bx plus c, we want x to equal 0. Now, we probably already know that it's just the c value, right? We're really well trained with that because of lines, and like we feel good about that, but roll with me. So we're going to do y equals a times 0 squared plus b times 0 plus c. I'm doing this because the x value must be 0 for a y-intercept, so we plug in 0 for all the x values. We can see that that just is gone. It's gone, right? Like, because it's multiplying by a 0, so we just get y equals c. So our y-intercept is always 0, c, if it is written in standard form. Very important if. Now, factored form is what you need if you're going to find the x-intercepts. So factored form gives us x-intercepts. And for an x-intercept, just like how on a y-intercept, the x value has to be 0, on an x-intercept, the y value has to be 0. If that doesn't feel right to you, like pause for a minute and think it through. I often have to remind myself of like how the picturing of it works, right? That one of them 0, so then the other one can be on the axis. So the y value has to be 0 for an x-intercept. So that means that if we have something that's in factored form, we're not going to plug in 0 for the x's, we're going to plug in 0 for the y value on the other side of the equation to figure out what those x values are that make it true. So if we take, let's say, y equals x plus 3 and x plus 1. This was one of the examples from 10.3. And if I want to find the x-intercepts, I'm going to plug in 0 for y. So I get 0 equals x plus 3 times x plus 1. Now, offhand, we don't really know how to solve this. Like if you try and change it back into standard form, it's going to get messy and you're going to end up trying to square root a square, and it's not going to work. Or square root a variable, like it's going to be a disaster. But if we just look at it for a minute, we should be able to see that since it's in factored form, and very importantly, we know that anything times 0 is always 0. Like 0 just, it kills it all, right? Like if you've got 1 0 in there, it doesn't matter what all the other stuff's doing. If they're all multiplied together, the whole thing is going to become a 0. So since anything times 0 is 0, all I need to do is make one of these x's create a 0 for that whole factor, and then the whole thing is gone. So let's take them one at a time. So if I have x plus 3, and I'm trying to make that be a 0 so that I can make the whole thing be a 0 so that it's true, because that's what a solution is, right? It's when like it's true. Well, the x value that would work there would be a -3, because -3 plus 3 would give me a 0. So x would equal -3. And to prove that to ourselves, that this actually works in my equation, I could go back to the original one, and I could be like, y equals -3 plus 3 times -3 plus 1. And I want to get a y value of 0, right? Because that's the whole definition of an x-intercept, is that y is 0. So I get y equals 0 times -2. So y would equal 0 times -2 is 0. So it worked. So x equals -3 is an intercept. It is -3, 0 is the coordinate point. Now, I had 2 points. I had 2 factors up here, though, right? And so that means that I actually have 2 options for how to make this 0, which makes sense because on a parabola, we often end up with 2 x-intercepts. So if I look at the other one, if I go x plus 1 equals 0, and you can do it in your head, like to see what it is. Sometimes they get more complicated and we'll actually just solve. So this one was not complicated, but just to show what I mean, that we've got x equals -1 would be the other value that you could put in for the other factor that would then make the whole thing equal 0. And so that same logic is going to work down here. So instead of having a -3, it's a -1. And we can see that the opposite term is going to be the 0 now, right? Because like this time I zeroed out this part instead of the first part. So this gives me a 2 times 0, but it still equals a 0, which gives me my second value of -1, 0. You may also notice that these numbers just kind of look like the opposites of what's up here. And that's true. Now, if these factors were more complicated, then that might fall apart a little bit. But that is, in fact, another pattern that you can be noticing and using. All right, let's do an example. So we're going to find the intercepts, both x and y. Find the intercepts. So let's take, I'm going to give it to you in factored form, 2x plus 1 times x minus 10 equals y. I want you to pause. I want you to try and do both things. So change it to standard form to get the y-intercept and use this, sometimes called the zero product property, to figure out where the x-intercepts would be. Give it a shot. All right, so I'm going to start with the x-intercepts. So I'm going to do this one first. This one looks more complicated, so I'm going to get it out of the way. To make this term be 0, I'm going to set up this equation. I could do this in my head, but I encourage you, when they have a coefficient in front of the x, just write it out. It's really easy to try and do it in your head and get it wrong on these. So that gives me 2x equals -1, because we have to subtract the 1 from both sides. I divide by 2, and I get x equals -1/2. So that means that one of my x-intercepts is -1/2, 0. We don't need to like test it every time. That was just me trying to prove to you why this works. On the other side, we're going to do the same thing. So x minus 10 equals 0. And I'm going to just show that step just in case it helps you. So that gives me x equals 10. So that means that if I plug in 10 into the original equation, that would also give me an output of 0, which means 10 is an x value that gives me a y value of 0, which means it's a place where it crosses the x-axis. Okay, so we've got x-intercepts here. Now we need y-intercepts. So a y-intercept is really easy to find if you have it in standard form. But if you don't, then you have to put in the work to get it in standard form first. So let's do that. So I'm going to put it in a generic rectangle this time. So 2x and 1 goes on one side. X and minus 10 goes on the other. Notice I'm just taking the values from up here. And that gives me 2x squared, x minus 20x, and minus 10. So then I can combine that into one expression, 2x squared, and then negative 20x and a positive x would be a negative 19x minus 10. But all I really care about is that c value there, because that's the part that's going to give me my y-intercept. So that'll give me y-intercepts are when x is 0 and then y is negative 10. So that's the other part of my answer. Okay, you're going to do this now. You're going to do one exactly like this for your practice problem, where you're finding the intercepts or the x-intercepts and the y-intercept. And of course, sometimes there's not 2, right? Some quadratics only touch once on the x-axis. Some of them never touch at all. We're going to talk more about those situations as the unit goes on. So let's say your practice problem is 3x minus 4 times x plus 5. You can make this be a y equals. Find the x and y intercepts. Good luck. Do it now.